Hello everyone and welcome to the Raspberry Pi lectures. In this lecture series, I'm going to present you the usage of GPIOs Raspberry Pi as an input. In the previous lecture, we had used our Raspberry Pi's GPIOs as an output to blink an LED. In this lecture, we are going to use an push button to take the input from the Raspberry Pi. So what we are going to build is we are going to build a circuit like this. I had prototyped Raspberry Pi on my breadboard. I had connected two LEDs just like the previous in the previous lectures, and the two push buttons. I had provided an external pull-up resistors with 10 kilo ohm resistance and extra 10 UF capacitor just to debounce the input. You can neglect that capacitors as well as the internal external pull-up resistance by using the internal pull-up in the Raspberry Pi. We are going to see that later in this tutorial. So we had connected our configuration like this is a 3.3 volt positive 5 volt provided to the external pull-ups, and the ground, this green wire is grounded here. We had used LEDs in common cathode mode, so that the logic high will turn the LEDs on and the logic low will turn the LEDs off. And the push buttons, we had used these push buttons in the negative active low mode. It means that whenever we press a push button, it will provide the negative signal to our Raspberry Pi GPIO. Because we had provided the pull-up resistance, it means that by default the value to the GPIO will be logic high, mean 1. I had used these pins. These are the board pin from 35, 37, 31 and 13, and the BCM pins connected to the LED is GPIO 19 and GPIO 26, and the push buttons are connected to the GPIO 6 and GPIO 13. So let's connect our PuTTY with our Raspberry Pi. 192.168.1.29 is the IP for my Pi. Pi is the username and Raspberry is the password, which is the default password. And I'm going to clear the screen and sudo su so that I can use in a administrative mode. And what we should do next? Well, we will just try to dive into the Python. So let's interpret some codings and import Rpi.GPIO as GPIO. Now import time to just give some delay, and let's try to add aliases with for our LEDs. In this tutorial, we are going to use the GPIOs as a BCM mode. In previous tutorial, we had demonstrated using GPIOs as a board mode. In this tutorial, we are going to use as a BCM mode, so that you will be familiar with both of the configurations. So the BCM is 19, pin number 19 connected to LED 1, and for LED 2 we had connected this with 26, and for switch 1 is connected to GPIO 6, and switch 2 is connected with GPIO 13, right? So now we had created our aliases for the LEDs and switches. What should we do next? Let's set up for the pin modes. GPIO dot set mode is GPIO dot BCM. Next, set up the LEDs. Set up LED1 as GPIO dot out and set up GPIO LED2 GPIO dot out. Okay, and for the using any GPIO as an input, same like you can do GPIO dot in. Okay, so this is will remain same for the switch 2. Now let's just try to read over push button. Well, for this I will use the command print GPIO dot input and switch 1. It is giving us 1 because switch is not pressed. Let's try to read it once more, and let's press the button, and this time try to read the input, which is 0. I had still pressed the button and the printed output will be 0. And same situation for the switch 2. By default it's 1. When I press the button it will give us 0. So that's the basic phenomena for reading a push button. But let's try to do something useful out of it. We can do that simply with a for loop. So let's create a for loop for I in range of 1 to let's say 400. And now if not GPIO dot input SW1, this will give us the print. If the push button is pressed, then what should we do? We just turn an LED on. Okay, so output LED1. How to output this is with logic high. Okay, so GPIO dot high. The next thing is in else form, and what to do, just turn off the LED. So this will turn the LED off. When we press the switch the LED will be on, and when we release the switch the LED will be off. That will be the simple logic for this. And when we press the button to the LED, it will be on and it will be off, because these statements are 400 times. The duration for executing this process will be very fast. So the last thing that we need to do if we want to implement this logic is to slow down the process. And for slowing down this process we need to add some delay in it. So for adding some delay, we had already imported our library for creating the delay, which is time library. So what we are going to do here is just to give us a smaller delay which will not interfere in detecting our switches. So this delay will be almost 2 millisecond. Okay, so now the program is halted because it is executing at outer stage. Okay, so what we need, as you can see here is a small logical error, because we had created we had given the command to turn the LED2 off instead of LED1. So just change that. It's just that simple. And again the else command, and instead of LED2 we need to write here LED1, and the delay, and the last one is time.sleep, and that's it. Now when we press the button the LED will on, and when we release the button the LED will turn off. Okay, so that's all for reading over inputs. Let's try to make something cooler out of it. So what we are gonna do is I had already created a script for you guys. I will give the link to that code in the description below. So please go to my website and check out the code for this part of the tutorial. So the code I had built for this tutorial is GPIO input EX01. So let's try to open this up with nano GPIO underscore input underscore EX01.py. So this will open up the code. Let's quickly review the code. First of all, I had imported my two libraries as before and created aliases for my LED 1 and 2, same like switch 1 and switch 2. Now I setted my mode for BCM and set up my LED as an output and switches as an input. The next thing I had by default turned the LED 1 on and LED 2 off. And next thing I had implemented in try finally, because to clean up my all the GPIOs for in range 1 to 800. This is just time multiplied by 2 milliseconds. It means it almost will be the um, 8 multiplied by 2, almost 1600 milliseconds. Okay, so if not GPIO input 1, it will detect if the switch 1 is pressed. This if switch 1 will is pressed, then it will turn the LED 1 on, and if switch 1 is not pressed, which will result in a high state, this will turn the LED 1 off. And meanwhile it will read an other GPIO switch 2, and if the switch 2 is pressed, it will blink the LED 5 times. Okay, so it will blink the LED 2 5 times, and else it will return the LED 2 off, and same delay as I delayed before, 0.02 milliseconds. So that's all for that. So just let's try to run that. And because we hadn't cleared up of our cleanup of our GPIOs previously, so this will result in some warnings which we can neglect, but we will keep as before. So these are warnings showing that the GPIOs are already in use, but you can neglect that and your program will work fine. Okay, so let's visualize what will be the output of this thing. If I press the switch 2, LED will blink 5 times, and when I press the switch 1, the LED 1 will be on, and if I release the switch 1, the LED will be off. And if I press the switch 2, the LED will blink again, and the phenomena will be applicable to the LED 1, and the program is terminated and the execution is ended. So that's all for today's lecture. Hope you enjoyed the video. If you like the video, please like this. If you don't like the video, please thumbs down, and and mention in the comment below what you liked about the video, what you don't liked about the video, what you want to learn in future lectures. Please mention that. And if you like our videos, and please subscribe the channel so that we can keep building such videos. So thank you so much and take care. Allah Hafiz.